So here's another example of applying mesh analysis. And as before, we first of all define the mesh currents. In this case, I've decided to define the mesh currents in a slightly different way. I think I1 is still the same, but now we're doing I2 counterclockwise. I1 is clockwise and I2 is counterclockwise. And I've already added the signs that I'm assuming for both I1 and I2 on all the passive devices. And just a reminder that the large plate here is the positive side and the small plate here is the negative side, and similarly over here the large plate is the positive and the small plate is the negative side. So let's quickly have a look at applying that mesh analysis algorithm. So remember, we've got to apply Kirchhoff's voltage law around each mesh. So for I1, we go into the negative side, so that's minus 12 volts plus VR1 plus VR2 equals 0, and then we get minus 12. We apply Ohm's law, so that's 6 times I1, which is VR1, plus, and now we have I1 and I2 going in the same direction, so the total current through R2 is I1 plus I2, so that's plus 12 times I1 plus I2 equals 0. Okay, so then we get, let's just write that out, so that's 18 I1 plus 12 I2 equals 12. And then for the I2 loop, or mesh for I2, we now have another voltage source here, and this one is going to give us minus 8 volts, and then it's plus VR3 plus VR2 equals 0, so it's minus 8 plus VR3 is just going to be 12 times I2, because there's only I2 going through R3, and again we've got VR2 is going to be 12 times I1 plus I2. And rearranging that, grouping like terms, we get 12 I1 plus 24 I2 equals 8. Okay, and then we can rewrite that as a matrix equation. I'll do that down here, and it's going to be 18, 12, 12, 24 times I1, I2, and that equals 12 and 8. Okay.